Hello fellow Scratchers! Today in our epic Scratch RPG tutorial series, we will finally be coding up the player to level collisions. Beginning simple with basic square colliders, and then gradually adding in support for the awesome collision pins that we put in place in the previous episode. Did you finish setting yours up? Now, you might assume that we'll be smashing the player hitbox into these collision pins, watching for when they collide, but since our level grid is stationary, we'll shrink the player hitbox back to a point, while expanding the tile pin hitboxes outwards. These changes actually cancel each other out and lead to exactly the same collision responses. But as it turns out, this is far more easy to code. Now notice how the collision pins form a simple grid layout. And simple is good, because we then have to deal with neighbouring tiles, where collision squares overlap. Oh, and did I mention, we also have to consider we've got 3 layers of tiles these days too. In overload? Well, hopefully not. It's a lot of fun, honest, so stay tuned until the end of this video to see how it all comes together. I'm excited. Are you? Enough talk, guys, let's get scratching. Open up your episode 7 projects, and before we do anything else, from the file menu, save them as a new copy. For this is episode 8. So here we are, able to walk over any tile we want. Well, not for much longer, right? Firstly, we'll simply prevent our player from walking over the tiles that we've painted on layer 1. That's these ones. All the coding today is going to be within the player sprite, and within the movement code. That's down here in the define try move custom block. We coded this up way back in episode 1, and it simply moves the player by dx and dy. So, we want to test whether this movement is possible, whether we collide, and if we do, then not let them move after all. But just before we do, let's just consider that we don't want any wall collisions when we are in the level editor mode. So duplicate the change player X and Y so that we can code up both modes independently. Check whether the level editor is active, if editor is greater than 0. And if it is, then change the player's position and stop this script. Exactly what it currently does. If you want to test that, then smash the green flag and you'll find that when not in the editor, we can no longer move. At all! But when the editor is open, well, there you go. We can move just fine. Great. Now that we are splitting the editor in game movement, this does open up another opportunity for us to accelerate the editor movement. With bigger levels, this can be super useful, so just multiply the dx and dy by 2 each. Next up, we'll consider the x and y movements independently for the normal game, so split them apart. Doing this will prevent us getting caught on walls. Okay, make a new custom block, naming it check solid all around, with an input of x and another input y. Run without screen refresh. This will eventually be used to check for collisions all around us on all layers, but right now, just for single tile collisions. We'll store whether we touch something solid by making a new variable, naming it solid, for this sprite only. For starters, we'll just set solid to 0, meaning no collision detected, and leave that as it is while we finish off the try move script. So we check solid all around player X and player Y. But we want to add dx to player X to test the movement along the x-axis first. We will know this movement is safe if solid comes back less than 1. Which it always will right now, and so we are free to then change player X by dx to do the actual movement. Great, so the y-axis movement is just the same. Duplicate the check solid and scripts below, changing it to be player X on the left, and this time player Y plus, and be careful to switch the dx for the dy input, as we are moving up and down this time. If there was no solid collision, then we chuck away the change player X and replace it with a change player Y. Perfect! That's the pattern of things. We are just missing any actual collision detection in our check solid script. But not to worry. Let's give this a test to reassure us everything is still working. And good news then, because I'm able to walk around again while not in the editor. Phew! Oh, and for those curious, yep, I can now dash super fast when the editor is open. Oh yeah, but enough of that. We want to test for basic tile collisions, right? So back in the code. It's this check solid all around script that we need to work on. And before we can do any collision checks, we need to know which grid tile is actually at position XY. Make a new custom block, naming it getGridIndex, with two inputs, X and Y. Run without, yeah, you know what. Then make three variables. Sorry, there's going to be a lot of these in this episode. GridX, or GX for short, for this sprite only. GridY, or GY, for this sprite only. And GridIndex, GIDX, also for this sprite only. We get the GridX by dividing X by 32. That's our tile size. But remember to round the result down using a floor operator. Calculate grid Y in the same way, setting GY to the floor of Y divided by 32 instead. And finally, to calculate our grid index, we set GIDX to the result of summing 1 with grid X, that's GX, and finally, we take GY and multiply that by Gmax to move up a grid row at a time. And then we sum that all together. If that doesn't seem familiar, then you can always rewatch my grid list tutorial to refresh your memory. So, under the check solid all around script, make use of the new getGridIndex block, feeding it with the X and Y inputs that we are to check for. Fantastic! A good point to test our scripts. Click the green flag and move the player around. We should find the player's grid position, and the resultant grid index is now calculating. Moving left and right changes the grid index by 1 and up and down by a whole grid max, which is counting in hundreds on my level. Could be different for you though. Cool, because with that we are ready to look for simple collisions. We'll get the tile under the player, a new variable to store that in. Call it tile, for this sprite only. And we set tile to item of grid. And the item is our calculated GIDX, of course. Nice. It all plugs together, right? So the absolute simplest collision check we can do is to see if there is a tile under the player at all. If tile is greater than 0, if it is, we count it as solid, so set solid to 1. Oh yeah, this is it. After 7 full episodes without any collisions, this is the moment of truth. Here we go, and up. Boom! Would you look at that? These full tiles are rock solid. There's no getting through these on any sides. That is so satisfying, right? Yeah, even the fence looks reasonable from the side. The other side? Well, a little overlappy. You might start to wonder though, did we need pin collisions at all? Okay, so this is perhaps where it starts to get a little bit off looking. We don't want to get this close to a wall, and oh man, there's no walking through this gap at all. I can skip over this with the level editor, but it turns out flowers are also solid, so we are stuck. Okay, delete these, and look at this. These are the real gotchas for full tile collisions. We really need to use those pins to let us get right up close to these edges. But let's not get ahead of ourselves. Right now we can't even walk over a flower or a road. Indeed, any tile placed on layer 1 of our level is impassable and solid. A quick win would be to look in our tile pin data and say only tiles with pins are solid. All others we can walk through with no problem. Separate off the if tile is greater than 0 check, and we'll get the pin values for this tile. Make a new variable, pin string, for this sprite only. Setting it to item of tile pins. Nice. And we want the pin layout for the tile under the player, and that is our tile variable. So lastly, we will look at the resulting pin string and just check if it is greater than 0. any pin layout with a 1 in it will be considered solid. Now this is exciting. Smash that green flag. Right, you can see the pin string is empty as we are not over any tiles right now. So let's walk over to the path. Okay, nice. I can walk on it, and that is a huge improvement already. And check out the pin string, and you can see it has an all 0 string pattern. That means there is a tile present, but it has no solid pins defined. And lastly, if we walk into something solid from below, we can see the pin string contains 1s, and so we are blocked because it's now counted as fully solid. So cool, we are making progress. And just before we continue, can I ask if you're enjoying the video so far? Please remember to hit the like button below. Doing so helps me no end. Thank you guys. Right, what's the next step? Well, although we can collide with tiles on layer 1, not all tiles are on this layer. Some are also on layer 2. Okay, well, the script responsible for detecting the solidity of a tile on the grid is these 4 scripts starting with the set tile here. Let's separate them off. We want to now do this twice, once for layer 1 and again for layer 2. We'll ignore layer 3 because it tends to sit above us in the game anyhow. It makes sense to pop this in a new custom block, naming it check solid at, with an input of grid index, GIDX, and we run without screen refresh. The set tile scripts can go under this new define, and then place the call to check solid at from where those scripts came. Then we need to bring the grid index variable out from our custom block, passing it in as the input, which means we can make the check solid script use the GIDX input as its new item number, like so. Okay, that's good. This should work just the same. Except now we can duplicate the check solid block to check the tile in the layer above this one. We do that by simply adding gmul togindex. That's the number of items in a full grid layer. Now, if either of these check solid blocks find a solid tile, they will set solid to 1. Let's give this a try. I'll first just walk into a standard layer 1 tile. They seem just as solid as before, so where's that layer 2 bush? Hooray! We have success! Both layers of tiles are now solid when they are found to contain pins. Well, you know what that means? All that's left to implement is the full pin collisions. Are you ready for this? Okay, we have the player and a tile to collide with. The tile has 5 solid collision pins, which I explained earlier would be represented as a grid of 9 collision zones, like so. These are numbered from 1 to 9, in the same order as a standard grid list. The first problem we face is that the collision grid is not aligned with our tile grid. This makes it hard to detect collisions outside of the tile they are defined within. To fix this, we offset the player and the tiles up and to the right by 1/4 of a tile. This brings the collision grid in line with the tile grid, and yet maintains the same collisions. You may have noticed this brings the top and right hand colliders outside the main tile now. That will be a problem, but it's one for later. Right now, we have enough to go on to get coding these pin collisions. We'll start then by offsetting our player by 8 pixels. Under the define check solid around, when getting the grid index, we first add 8 pixels to X and 8 pixels to Y. Funnily enough, we already observe the initial effect of this by running the project and colliding with solid tiles from the left. We are no longer able to get as close to these blocks as before. This is the desired effect, making it feel like our player has width. Of course, as things stand, the opposite applies to collisions walking left, where now we can actually overlap even more than before. Just ignore that for now, we are not finished coding. The next step is to work out which of the 4 pin squares the player is within. We'll code this within our getGridIndex script. And now we might as well duplicate the entire script, as getting the collision grid index is very similar to getting the original grid index. Firstly, the collision grid splits the tile grid into 2 by 2. So we must halve the tile size to divide not by 32, but by 16 in both cases. However, this will tell us how many half tiles across the entire level the player is located. So to switch to return 0 or 1 for this tile, we mod the result by 2, keeping it cycling around from 0 to 1 to 0 and back to 1 again. Do the same now for GY. Right. Lastly, the pin collision index. We need a new variable to store this in, naming it just pin, for this sprite only, and switch the setGrid index for a set pin. Nearly there, this collision pin layout has just 3 pins in a row, so the row multiplier at the end here should be changed from Gmax to the plain old number 3. Let's give that a quick sanity check. Run the project. And with GX and GY and pin variables visible, we can see, after we begin moving, the GX toggles between 0 and 1, great, as does GY when we move up and down, and the pin value is only ever matching pin 1, 2, 4, and 5. This is the number of the pin under our player. So exciting! Now, if you see anything other than pin 1, 2, 4, or 5 after you've moved, then something is up. Go back and check your scripts again. But if all is good, then yay, we are going to code up the first actual pin collision now. Find the define check solid at block. This is no longer quite fit for purpose, as rather than looking for entire solid tiles, it needs to now apply to only a specific pin of a tile. Therefore, right-click the define block and choose Edit. And we'll add a text label at the end, @pin, and a new input, pin hash. Cool. Just before we code that up, let's see where this block was used. Here, in the check solid all around, that's where, and see these empty inputs? So, we just calculated which pin we'll be checking, so drop the pin variable into both the solid checks, both layer 1 and layer 2. Great! Go back now to the check solid at script. Let's implement the actual pin lookup. And it's quite straightforward, luckily. We've already got the pin string. All we need to do to access the individual pin values is use the letter of pin string. And the letter number is given by the new pin hash input we've just passed in here. Splendid! So if the pin value is greater than 0, we set solid to 1. Now this is perfectly good for now. But looking ahead, let's make a small change. As we check through the pins and layers of this potential collision, we want to keep track of the most solid collision, not just the one value here. Instead then, check if greater than the value already in the solid variable. And then, if the new pin is greater, set solid to the value of the pin, letter pin hash of pin string. Cool, I like that. It will keep track of the largest pin collision value from our pin string. Guys, we've completed the first part of the pin collisions. Excitedly smashing that green flag now. I'm going to try a simple collision to begin with. These full-size tiles seem to work just the same. We are now nicely far away. That's great news. But where things get fresh is when we try to collide with a half tile, like this left-facing fence over... Here goes nothing. Oh my goodness, look at that! It works, a half-tile collision. I'm so happy. Sometimes the math befuddles my mind, but somehow it all falls into place. Yes, and collisions from below are also correctly handled. So we are oh so close now. The pin collisions that work are the ones that lie in regions 1, 2, 4, and 5. It's a shame then that the pins we need for right-hand collisions like this one are currently excluded from our collision scripts. As such, we can walk right through them. Let's just back this up a moment though. The solution to this problem is not as complex as it may seem. Let's look at the tile next to this one. It too is divided into 4 collision pin regions, 1, 2, 4, and 5. What you might see though is that pin number 1 on the new tile sits perfectly on top of the elusive pin number 3 of the tile to its left. Likewise, pin 4 sits over pin 6 of the tile to its left. And this is the key. Whenever we check any pin 1 or 4, that is, the left side of a tile, we automatically also need to look at the corresponding pin 3 and 6 of the tile to its left. Simple. Want to try this out? Let's code. Find the define, check solid all around. After we get the grid index, we currently check for solid pins on layer 1 and 2. Separate these off, and we'll place them in a new custom block, naming it, appropriately, check solid across layers, with an input, grid index, GIDX, a label, pin, and a final input, pin hash. Run without screen refresh. Great, pop those 2 blocks in there and make use of it right away, dropping it back from where we took the blocks from. And now the inputs need matching up. The GIDX variable comes up here, and the pin variable drops into that pin input. Then back down in a new block, the GIDX input goes in first, and pin hash second. Just need to do the same for the block below too, replacing them both and cleaning those old ones away. Cool, make a little space. We want to check if we are looking at pins 1 or 4, but since GX will always equal 0 in these cases, we might as well just check that instead, if GX is equal to 0. In that case, we then want to check solid across layers. Again, this time for the tile to our left. That's GIDX subtract 1. And the pin number? We need to move from 1 to 3 and from 4 to 6. That's just adding 2 to the pin, right? So drop in a pin plus 2. Okay, so here we go. Right collisions should work as before, but left collisions... And look at that! What an awesome sight! After all this work, it's perfect. Next up then, we need to do the same for the top row of pins. Pins 7 and 8 follow a very similar line to 3 and 6. You'll find pin 1 always sits on top of pin 7, and pin 2 sits on top of pin 8. So we are looking for any collisions on the bottom row now. Here we go then. Duplicate that if check, and we can switch to look for the bottom row of pins if GY is equal to 0. Then instead of looking at the tile to the left, we look at the tile below us. To get that, we subtract a full grid width, G max. Lastly, we switch pins. Up 2 rows of pins from 1 to 7 and from 2 to 8. That's just adding 6, right? Exciting! Let's give it a test. Left collisions, check. Upward collisions too. So downwards? Man, this is sweet. We are simply rocking now. Are we done? Well, not quite. There's this one little corner case remaining. Literally. See how we can sneak into the corner here? So we have this one final pin unaccounted for, pin number 9. And this one sits also under pin number 1. Wow, pin 1 sure does overlap a lot of other pins. Come on then, duplicate the last if and drop it inside the first if like this. When both GX and GY is equal to 0, we are looking at the bottom left pin, pin number 1. So now, as well as subtracting Gmax from grid index, we also need to subtract another 1 to move diagonally down and to the left by a tile. And the pin number? This is always going to move to pin number 9. So forget all the pin pluses and just enter the number 9. Guys, believe it or not, that was the last script of the episode. Smash that green flag because we are going to play. Go on, try and get into that corner now. It's not having it, I can tell you, and that is great news indeed. Wow, all these collisions are working just great. How about this little entrance? Oh yes, we can get in, at last. That's awesome. So how about these thin walls? We neatly hug the outside. This lamppost? Yeah, we hug that too. This looks too cool. The outside of this... What? What's going on here? Is this house on the wrong layer or something? No, apparently not. It's on layer 1, so how come we are not colliding? Oh, wait. If I press the E over the house, it's not selecting in the palette. This means this house was drawn before I coded up the sprite palette fencing, so it's probably set to a negative costume number or something on my map. I need to redraw it with the correct costume numbers from the palette. And then... Yeah, there we go. Collisions repaired. It wasn't our collision code at all. Any other problems? Ah, here's one. The black needs to be a collision until we create actual doorways. So I'll find that black tile on layer 1, pressing E to identify it. There we go. And then toggle the pins with the P key and fill it out with pins. And with that, right back into the game, and the collisions are updated. Really nifty. And that, my friends, brings us to the end of another episode. If you enjoyed watching, then please take the time to smash that like button to show your appreciation. And then, if you haven't already, there's no better time to subscribe to this channel, clicking the bell notification to ensure you don't miss the next exciting episode when it drops. If you just can't wait, then there's also my early access channel membership, which also comes with added perks like priority replies to comments and custom channel emoji. Lastly, I want to give a shout out to my awesome YouTube channel members and supporters over at Patreon. This channel wouldn't be the same without you. So that's it for today. Thank you for watching. Have a great week ahead and scratch on, guys.